All right. Hello, everyone. Day 3 of the 60-day tech challenge I'm started. As you all know, we're going over cloud and cybersecurity as it pertains to each other. So securing the cloud and just going over cloud engineering and DevOps engineering skills of 2026. So again, let's get started. We're at day 3. Today is the application load balancer, the ALB, plus the private EC2, plus the multi availability zones, and then plus health checks. So we're gonna create a application load balancer. Um, looks like we're gonna connect it to our private EC2, so our private EC2 can have internet. Because we yesterday we got rid of the internet gateway at the end of the lab, so we have no IGW for our private EC2. We are not using um, a NAT for it, or yeah. So let's get started. Let's look at the architecture. So by the end of today, we will understand that the internet goes through the internet gateway, and then that hits the application load balancer. So this must has a public internet facing IP, and then it routes to your public subnets A and B. Within those, we have the private subnets, which is A, and or server A, and then server B. Um, and then we have what we call a target group. We'll learn about that today, and that will then touch our application. So this is uh, our flow, and this is what we're going to learn today. What we're going to do today: build and break. You know how we do. All right, let's get it. All right. The internet reaches the ALB. The internet does not directly reach each of your EC2 web servers. So that's the whole lesson today. So first step, if we're going to verify the VPC is still here. So we're going to go to our console and make sure our virtual private cloud is still built as it should be, because I have not deleted anything. Jesus, look at these. Sorry, I got caught off guard by my expenses. We're gonna go to VPCs, your VPCs, aka, and here it is, project VPCs right here with that IPv4 starter block. All right, so that's good. So now let's check our subnets. Make sure we still have our public 1A and public 1B, and our private 1A and our private 1B. Let's go check right now. So as you remember, here is public 1, and here is public 2. Oh, excuse me, wrong project. Here it is right here. It's project subnet public 1. Here we go. And here's project subnet number 2. Here we go. Here is project private 1, and project private 2 is at the very top. There you go. Perfect. I might get rid of these other ones so this could be easier visibility. You know what? We'll leave it for now. I'll worry about that offline. All right, so our subnets are still there. Do not create anything yet if this doesn't match. Well, blah, blah, blah. It's there. So now step 2, we're going to verify our public route table is still there. This is where we created our IGW for our public subnet. Let's check right now. So VPC, route tables. What do we name it? Project RTB public. Yes, we did. So project route table public. And within there, we got to check its routes. And here we are. The internet gateway is right here, and the local network is right here. So again, anything that on the internet will talk to our internet gateway for our public IPs or public subnet, and anything within our network will use the local. So our public subnet will talk locally to devices on the same VPC. All right. Good. Check subnet associations. Both public subnets should be associated with this route table. Subnet associations. Here we go right here. You got public 1 and public 2, East 1A and East 1B. So as you can see, both of our public IPv4 CIDRs are within this route table. So both of our public subnets have access to the internet gateway. All right, now we're going to check the private route tables. Our private subnet route table should at minimum have we need to, now we're gonna check the private one. We're gonna make sure it has our local. Remember, we got rid of our NAT gateway, so we should only see our local. So let's check our private now that we already verified our public. Remember, private has 2, so we're gonna check both of them. Yep, it says black hole, which is perfect. And we're going to check the other one, routes. And, oh, we never put it on 2. Okay, we only put it on 1. That's right. So it does say black hole. That's good. Let's go ahead and fully remove this route, because we don't need to see it at all. Goodbye, black hole. By the way, AWS, that's a crazy name. But, we'll keep moving now that the black hole was removed. All right, so our application load balancer can still communicate with the private EC2 instance through our local. So we're good. No NAT is required for our application load balancer to EC2 traffic. Lock that in. So we are replacing our NAT gateway with the application load balancer. That's more of how modern architectures are built, due to high availability, which is really the whole purpose of what we're learning today. We're learning real production architecture. We're not the previous way of just adding the NAT gateway that works, but in a real environment, you want multiple availability zones. Just in case something goes down, you could quickly switch over to one of your redundant setups. All right. And when I say quickly, I mean automatically. Say your nginx server went down and it had a production app on it. Let's say it's Netflix. You think Netflix is running off of one VPC, or excuse me, one subnet? No, it's going to be created in multiple subnets. That app will be hosted in multiple subnets and multiple different availability zones, so it could stay running. Just in case something fails, it'll be able to keep running. I'm sure there's a lot of availability zones when it comes to these applications that's used around the world by millions of users per day. We'll get into that during this 60-day challenge. And if not, I have a 90-day advanced challenge right after the 60-day. So we'll get into it. All right. So let's go to find your day 2 private EC2. Go to EC2 and then instances. EC2 instances. Here is our private subnet. There we go. So it's going to be this is going to be our first backend server. Let's press it. Check the private IP. Here we go. We're going to rename it to day 3. Oops. We're going to rename it day 3. That's what it said. Day 3, Web A. Oh, new name. Voila, magic. Day 3, Web A. We just renamed it. We're actually, let's pull this. No, we're fine. We'll keep it like this. All right. So this is server A. Availability zone is US East 1, and it's private subnet A. All right. All right. So now we're going to verify nginx is still on the server. Make sure that the app is still running. We previously installed nginx on the server. We need a way to access this instance because our NAT is gone. SSM may currently show the interface as offline unless we later provide AWS Systems Manager connectivity through another mechanism. But for this lab, we could use the Bastion approach again if necessary. So we are going to do that. Need to pull up good old terminal. Here we go. Let's keep this up. I want to see this. So we need to get into the server. Once on server. Let me see. Does this work? Password. Ooh. Actually. Step 5, we need to get into the server again. I actually cannot memorize the command to fully get into there, so we're going to use ChatGPT's help real quick to give me the command so we can get into it. Right. I'm trying to get into the... Okay, so it's just literally SSH and then the server name. Got you. I'm going to try to remember that next time I need to do this. That's going to be the my challenge. I think since we changed... Yeah, we never changed the SSH alias, so we got to use the name from yesterday. All right. Once that SSH works, we're gonna be inside the nginx server, and I can run the sudo command. Give it a minute while it loads. I'm a little impatient. Let's see. If it doesn't work, then this is cool. We'll be able to troubleshoot why the SSH isn't working, although it should work. You know what? Let's reopen terminal. Let's try this again. So it's taking a long time. I don't know if that's a good or bad thing. Well, I think it's a bad thing. I think something is not working properly. You know what I'm going to do? I'm going to check and make sure that we still have SSH set up on this. Which is in... So this is the instance. I'm going off memory right now. I know this is where we gave it SSCM. We're looking for inbound traffic rules. So that's in our security group. And then we are going to... I think it's Launch Wizard 3. Yeah, SSH is enabled. I'm not sure what's going on. We'll figure it out. Take a screenshot. Listen in the chat. I just told chat SSH seems to not be doing anything. Oh, the IP address most likely changed. Okay. How do I cancel this? Do I just have to term? I'll just term it. Oh, that worked. Okay, so it gave us the IP address. Now we gotta edit it in our file. What? Control O, enter, Control X, enter. We're gonna copy this actually. Paste this. We're gonna show chat that it got a new IP, and then we're gonna have to update the file. Oh, I gotta exit. That's why that happened. Okay. Alright, it still isn't working. We're gonna get the error log for it. Hang in there. This is just troubleshooting at its finest. I don't think we did. Alright, let's verify this. So we're gonna check if we did get rid of the SSH setting. Oh wow, we did get rid of it? Okay, I guess we did. Let's add it back. Custom. Alright, just create the rule. The rule is back. Let's try SSH again. We gotta terminate this. Reopen it. Alright, now we're gonna try to reconnect to it. Alright, now we're in there. So yeah, we did get rid of the inbound rule. I was looking at the wrong security group. I thought I was looking at the right one. Our naming convention is a little off. We have things labeled day 2 and stuff like that. I also have a ton of security groups in there, so it's a little confusing. It's a little messy. I'm going to clean that up. So moving forward, everything is pretty clear. But maybe in a real environment, this is good because you need to be able to figure out which security group goes with your EC2 instance. Even there's 100 of them, you need to know. So tags and everything like that become important. All right, great. So we are now here, and we're going to run our next command. And here we are. The nginx HTTP and reverse proxy server loaded. It loaded good. It's active. It's running. So this goes to show our nginx is running successfully. Our nginx server. So good. Perfect. Step 5 is good. Nginx is already running on server A. We're inside our EC2, our private EC2. Now we're gonna add this name to our file. All right. Now we're gonna add some text into this server so we can see that it's server A. Good. Now we're going to do a curl just to see it ourselves. There it is. Perfect. Perfect. Good job. Keep it pushing. On to the next step. Step 7 is next we're going to launch the server B in private subnet B using the US East 1B VPC or EC2. Perfect. Step 6 is EC2 instance. Step 6 is complete. Your file shows nginx server on server A and curl HTTP localhost is returning the custom day 3 page exactly as intended. So server A is ready. So as you can tell, we were in server A and it has everything we need. We just gave it some HTML so we could decipher which is server A, which is server B, because when we load our application load balancer, we want to be able to tell what's what. So we're now gonna launch the next server. Let's get it. So we're gonna create a server. Oh God, it just moved us. Slide back down, please. All right, let's go to EC2 instances. It just loaded, then it went away. How crazy. We're gonna launch the instance. Now I don't know what we're gonna name it. I need chat to come back, stop tweaking and geeking. All right, good. Here it is. Day 3 web B. Perfect. AMI Linux. Perfect. T3 micro. Where's that at? Right here. Here we go. We're gonna give it a key pair. This is our day 1 EC2 key. That's just so we can SSH and not have to use a new key every time. Our VPC is gonna be the project VPC. Let me make sure that's the right one. Nope. Project VPC. Join our network. We want private. We want private subnet US East 1B. That's public. Private. Oh, we're already on it. Good. So we have the right subnet. Um, mm, mm, mm. Where does it show our CIDR? Here it is right here. 10.0.12.0/24. Great. AZ is US East 1B. We're going to rename the security group. Sure. We'll keep the description as it is. Where is AZ? I just want to verify that that's there. Oh, here it is. US East 1B. Okay. So now we're gonna launch. It says, for now, don't worry about HTTP from the ALB yet because we haven't created the ALB security group. We'll configure that cleanly in the next steps. All right, we're launching. All right, it says successfully created. Let's pull it up. Oh, let's go to it from here. Here it is, Web B. And here we are. Here we are on to step 9. All right, a good pace, fellas. All right. All right. Step 7 is complete. Oop, we're going to step 8, not step 9. So our screenshot is showing that day 3 WebB is running with our private IP. There's no public IP yet. It's in our project VPC. It's in the VPC we created. T3 Micro. All right. So now we're about to get server B ready for nginx. Because server B is private and that is deleted, don't try DNF install nginx yet. It won't have internet access. Do this next. So it looks like we're going to give it internet access, or we're going to give it SSH so we could use the Bastion approach. Go to day 3 web 3B, go to security. The day 3 web. Where is that security group? Here it is right here. So we're going to go to the security group. We're going to add the inbound. Oh, it's already there. I already saw SSH. So it's right here. As you can see, SSH is already here. Then from your Mac, we'll add a new SSH alias for server B so you could jump through it. All right. All right, I think I just run this directly in my Mac. Let's see. Let's exit out of here. Maybe I did that right. I don't know. Let's see. Um. Okay, so we had to open up the file. All right. This is why repetition is perfect. Here we are. And it is within here. So we're going to go to the bottom and we're going to add this. We're going to add host 3. Let me get some space here. Perfect. Control 0. Enter. Control X. I said 0, but it's O. Now we're going to SSH into it. Yes, add this key. Here we are. We're inside the EC2 instance. As you can see here, we're an EC2 user at IP 10.10.242, which looks to be our project. That was within here. We're going to EC2. Why did I press VPC? Sorry, guys. I just want to see our EC2's IP just to show that we're in it. In it to win it. I'm sorry, y'all. I'm a little tired. 10.10.12.242. Perfect. We're in day 3 web B server. So let me show chat that we're in here like swimwear. Paste this. I gotta use the bathroom, y'all. I might have to be right back. And by be right back, I mean a little 5 to 10. Little 5 to 10. All right, we're in server B now. The SSH alias is working, and you landed on IP 10.10.12.242, so that part is done. Now we need to get nginx onto server B. Because this server has no public IP and no net, the install won't work because there's no internet. So let's prove it. Show that there's no internet. This is what we're doing first. So it's a good timeout after 10 seconds. It's gonna try to curl the site, but it's not gonna be able to. So then we're gonna actually see the install fail. ChatGPT just wants us to go through this just to prove it. Yeah, it's gonna fail in a second. As you can see right here, nothing is installing. So I'm gonna actually send the results of this once it fails. Then I'm gonna use a bathroom break. Hurry up, it failed, buddy. You know what? I'm gonna use the bathroom. I'll come back. mosquito in the bathroom. I seen it when I got up. Alright, I'm back. Let's get it. So, okay, it's still running. Obviously, that means it's not going to work. Can we cancel you somehow? Huh. How? Okay. Finally failed. I had to do all that. Alright, cool. We expected that, though. Perfect. All right, so we have another option than a NAT gateway. We're going to create something cleaner and cheaper. We're going to create a S3 Gateway VPC Endpoint. So a S3 bucket Gateway VPC Endpoint. This works well here because Amazon Linux package repos are stored in Amazon S3, and AWS documents that S3 gateway endpoints let private instances reach S3 without a NAT gateway or internet gateway with no additional charge for the gateway endpoint itself. So this is a free option. So I don't know about y'all, but I like free, and we are going to do the free option. All right. Needed to reload. Come on. Come on, man. All right, we're here. All right, so let's go to VPC. Endpoints. Private link and lattice. So as you can see, this is where we're creating our link for our private network. We're going to name it day 3 S3 endpoint. Service category is AWS services. Then we're going to search for this specific service. Here it is right here. Choose gateway type, not inference. Gateway. So we're creating a gateway. And then VPC is our project VPC. Alright. In the route tables, we're going to create the private, we're going to use the private B subnet. Alright. So those are the two AZs. We have one A and one B. That's the redundancy. Policy, we're using full access. So we're going to allow it to have full access. Then we're going to create the endpoint. All right, so it says AWS will add a S3 prefix list route to that private route table automatically. That gives server B a path to S3 without giving it general internet access. Let's actually just check that. Oh, look, it's right here. Okay, as we can see here, it is being routed to that. And now we're going to try to install nginx, which we should be able to now. It just installed. Or is it still installing? I think it's still installing. Great. Let's give it a second. Then we're going to run this next command. Alright. Just completed. And now we're going to run the sudo system control. We're going to enable the server. Great. We just did it. And now we're going to check and see if it's running. Yep, it is running. Awesome. And now we're going to add our HTML in there. Boom, boom. That way we can see that it's server B. Remember, we added our HTML to our server A. And now we're gonna see it here. Boom, perfect. It shows us the server. So we changed the default HTML about thank you for using nginx to our own custom. Alright, so we are good now. We have nginx installed on server B. So server A has nginx, server B has nginx. We're good. Great. So server A and server B has nginx. Private server A and private server B. We installed it on A yesterday using our NAT gateway. Today we did it different. We used a S3 endpoint, a VPC endpoint for it's I think it's called S3 endpoint. All right. All right. Move this over a little bit. Move this here. All right. Now we're going to create our security group. So let's go back to EC2 security group. We're going to create a new security group. This is our day 3. It's for our application load balancers. You need to have a security group before you create it. Where the whole point of it is to allow HTTP from internet to day 3 application load balancer. We're going to choose our project VPC, so it's within our network. We're going to add the HTTP inbound rule. We're going to choose the source, which is going to be 000, which is the internet. That looks good. Protocol TCP, anywhere IPv4, that's fine. Oh, let's verify. Should it be anywhere IPv4? Let's make sure. Let's get our outbound. Next is we're gonna do out. All right, one second. Let's take it a step at a time. All right. All right, we're gonna create it. We're gonna open back up that security group while we're still in it. Well, we're gonna update it, excuse me. So here goes our inbound rules. We're gonna edit. Oh, excuse me. No. This is our application load balancer. Now we're about to go to our web security group. I get it. So we need to we need to allow traffic on the internet onto that as well. So day 3 web security group. This is our private EC2 server. Remember, we allowed it to connect through SSH. Now we're gonna allow it to connect HTTP, and we're gonna attach the reason it's gonna be able to do this is because we're gonna add an application load balancer. So type is HTTP. Source is I guess we keep it custom. Source type, I mean. And we're gonna use our day 3 application load balancing security group. Perfect. We'll save that. So here it's telling me make sure both web servers have the day 3 one. All right, so we just checked one web server. Trying to figure out where I would check that at. Well, we could go to the 2 instances and check through there. Let's do that. Our instance types. No. Instances. So web A has, let's go over security, is using the I don't think it does. Using a different security group. So I think this security group needs to be updated. So we're going to go to Actions, Security, Change Security Group. So there it is. Adding that security group now. We're going to save it. Then we're going to do the same for the other EC2 instance. We're going to do it for web B. So we'll go to Action, Security, change the settings. Day 3. Oh, it already has it. Okay. So web A and web B has it. All good. All good. Now web A and web B has that security group. Web A now has 2 security groups. Web B only has 1. So we created web B earlier today, or previously in this lab. So we assigned the security group then. All right, we're all good. All right, now we're going to create the target group. Create target group. Target type is instances. Target group name. It's going to be day 3 web tech TG, so web target. Protocol is HTTP, port 80, IPv4. Project VPC is the VPC we're going to be using. HTTP1. HTTP/. Keep moving. Then we're going to register. What does that mean? How do you do that? Register the web servers where? I think that's outdated. Let's just see. Oh, it's on the next page. Well, you should have said that. All right, here's our different web instances. We're going to select both of them. We'll keep port 80. Include as pending below. So those are targeted. Click next. Review and create. And we're going to create the target group. So now we just created a target group. Let's kind of Google that. An AWS target group is a logical grouping of backend resources used by Elastic Load Balancing to route incoming user traffic. A load balancer listener evaluates its configured rules, determines the correct target group, and forwards traffic to the registered healthy resources within that group. So this is creating a group for your load balancer to know what to forward the traffic to. And we just forward it to our private server A and our private server B. So this makes sense. This is how our private servers are going to be talking to the internet. They're connecting through our application load balancer, and our application load balancer needed a target group so it knows where to send the traffic, route the traffic. All right. Let me press that. There we go. All right. The target group is created. Both targets are registered. The screenshot shows 2 total targets, 0 healthy right now, which is expected, but there's no load balancer associated yet. Next is step 17. Fuck, I don't mean to do that. Hate this, man. ChatGPT, y'all need to update this, bro. Just because I minimize something, or you know what I mean, you shouldn't be doing all this. Once this loads, we'll continue. Sorry, y'all, I'm just a little tired. I get tired every day, but don't matter if we're tired. We got to keep pushing. That's one thing about this. I don't care if I'm tired. Tired's an excuse. It's only a limitation. People were more tired than me in worse situations. Let's refer to prisoners, slaves, people that are in situations like that, people at war. They're in way worse situations than me, and they're tired, and they have to keep pushing. So who am I to say I'm tired? I'm not tired. It's just easy to say you're tired. You know what I mean? All right, chat, let's get loaded. So next we're creating this application load balancer. I'm sure it's right here. We're going to go load balancers. We're going to create the load balancer. And then we're doing the ALB, so we're going to create application load balancer. But here is where I'm going to need to talk to chat to see exactly how we're going to build this. Whenever it loads, we'll continue. Alright, great, here we are. Alright. Load balancer name, day 3 public application load balancer. Keep it internet facing, because this is going to be our means to the outside. Add our project VPC. Network mapping. We're going to choose our availability zones. There goes project subnet public 1, project subject subnet public 2. We're going to choose the correct security group, which is our day 3 web target. Whoa. Oh, I'm tripping. We're going to use our application load balancer security group, not web target. I'm jumping ahead. We're listening on port 80. Forward to our target group, which is day 3. Here we are. And then we're going to create. Boom. Go back to day 3 web target and watch the targets. After it starts provisioning, we're going to go back to the target groups. Here it is. And we are going to watch this change. There it goes. Give it a minute. Because they should move from unused, not healthy yet. Unused. Into health check evaluation. I don't see health check evaluation exactly. Let's just send chat a quick screenshot. Make sure we're looking where the terminology is still the same. You know, chat sometimes be outdated. All right. So we got to give it about 30 to 60 seconds, and then we can refresh the page. Let's go ahead and refresh it now. All right, we're still waiting. Man, chat, y'all need to fix this, man. I'm getting tired of that one right here. You gotta, well, you know what? I really need to just get a second monitor. That's on me, y'all. I am trying to use my MacBook as my setup, but I really need my Windows PC. All right, we're still waiting for these to say healthy. Just waiting. Keep on waiting. Waiting on the world to change. Keep waiting. Wait on the world to change. Waiting on the world to change. I'm still keep on waiting on the world to change. Alright, it's taking a little longer than expected. I suspect they're, talk too soon, cause 2 say healthy now. My bad, y'all. I almost suspected something was wrong. Great. That was definitely more than 30 or 60 seconds. That was more like 260 seconds, but it's all good. All right, now we're going to go to our load balancer again. And we are going to go to day 3 public, and we want the DNS name. Here it is right here. We're going to copy it. And then we're going to open this on our browser. HTTP, as you can see. Let's take out the S. That's the issue. Oops. We just want, no. Take all this away. And then we're going to type it in old school way. HTTP, boom, boom, / Here we are, baby. That's perfect. That's what I like to see. Server A is Gucci, or it is good. Yep. Yep, and you keep refreshing, you see B. Amazing. So it shows that both servers are live and on the web. That's good. It's good. All right, so our day 3 architecture is working. So we created the public application load balancer. We gave it inbound rule in our security group for HTTP, so it can access internet. It's internet facing. We then applied that security group to each of our different servers, server A and server B. So they inherited the they inherited the security group, and also we gave it an inbound rule so it can inherit the internet gateway through the application load balancer. So now, since we got everything created, we're now going to start breaking things and learn it backwards. Okay, so we're going to break nginx on server A, and then we're going to watch the application load balancer fail over to server B. Perfect test right here. Oh, God. Oh, I'm tripping. I'm in the wrong thing. There you go. SSH. Private day 2 private. We're in it. We are going to stop nginx while we're in server A. And we're going to verify that we killed it. Stopped nginx, as I can see right there. Perfect. Now we need to get out of here. There we go. Go exit. Actually, yeah, we're gonna. Well, let's see. I don't know if we need to exit yet. I don't know if we're gonna run it again or rerun it. EC2. We're gonna check our target group. We're gonna check our targets. Server A should say unhealthy. Right here, we're waiting for this to change. There it goes. There's the unhealthy. While server B stays healthy, so that shows our nginx server was destroyed. Then we're going to refresh the browser several times. We're going to only see B. Got it. Done. Great job. As you can see, we killed the nginx server, and our application load balancer only has our server B live. So now we're going to restore it. Thank you. That's why I did not exit out of it. So we're going to fix it. And then we're going to do the same to B most likely, I bet. So now we just restored it. We're going to check. It is back running. Perfect. We're going to wait for it to say healthy again. So we're going to wait. Give it a second. Waiting on the world to change. We just waiting for this thing to say healthy. I'm gonna spam refresh. Nah, we'll just wait. We'll give it a minute. I'm gonna check my phone. Keep on waiting. Wait on the world to change. Alright, still waiting. Let's refresh. Still unhealthy. It's gonna just take a minute, y'all. I'm convinced it's Gucci. It's good. So let's just give it a minute. Still waiting. I'm gonna send this to chat real quick because we've been waiting quite a while, but it did take a while the first time. Oh, there it goes. I should not have. I always do this. Cancel chat. My bad. Ignore that. All right. So as we can see, it's healthy again. Now we're gonna go to our security group, and we're gonna break. We're gonna break our inbound rule. So now we're gonna get rid of HTTP on our application load on our web security group. J3 web security group. We're gonna right here is our HTTP. We're gonna check that and go to edit actually and delete it. Within here we had our day 3 ALB security group attached to it. So this is what gave us connectivity to the internet. We're getting rid of it. So now we're going to see both servers say unhealthy because our security group is now blocking the ALB. So the health checks are going to fail. And that is going to be essentially the lesson. So let's give this a second to fail. But as you can tell, our EC2 instance is still running. Our nginx is still running. The route still exists. It's just our security group for our day 2 web servers is now blocking the HTTP inbound rule coming from the application load balancer. So there's no comms between our application load balancer and our 2 servers. And that's why our registered targets are going to fail, because this is our application load balancer's target group. Boom, both unhealthy. Perfect. So that proves my theory of what I was just saying. And now we're going to restore it by going back and adding that same HTTP inbound rule. We're going to add another HTTP. Our source is our ALB security group. And then we're going to save. Then we're going to go back to health checks. Or target groups, excuse me. Within our target group, we're going to look at the health checks and the health status. And we're going to wait for them to say healthy. And then next, we're going to break our health checks. this takes a while, so I don't know. Spark a cigarette. Do whatever you do. But be back in 4 minutes. I give it about 4 minutes. It should load. All right, they're back healthy. Great. Now we are going to break the health check. So off to our target groups. Back to day 3 web target. Health checks, edit, and we're gonna change the path to does not exist. Save it. All right, so we're gonna go back to our target group. We're gonna look at it, and it's gonna fail. Or is it not monitoring? Go back, targets, and it will fail. Just want to verify what that exactly did. So changing the health check path from / to / does not exist told the ALB, don't check the normal homepage anymore. Check the specific URL path instead. Oh, I get it. Okay, instead of checking just the regular homepage, it's checking this exact page, but we don't have that page. So we're going to wait for this to say unhealthy. They both say unhealthy. Okay, so in real environments, we use /health or /health for our endpoint. All right, it shows unhealthy. I'm sure we're going to just put it back, and then that's going to be it. So we're going to edit that. We're going to just keep it on /. So it hits our home page. We're going to save. And I believe that's our last break. And then off to our 10-question quiz. And then we are done. I believe this weekend, I'm going to draw this. No. You know what? Tomorrow, I am going to draw the architecture of what we've done in these first 2-3 days. And I will upload it to GitHub. That's exactly what I'll do tomorrow. All right. Break 3 worked. We're all good. Now it's telling me restore. I already did it. Healthy. Boom. And then, all right, we're on break 4. There's another break. Okay, once they're healthy, we do break 4. Stop server A completely. Prove the site still works through server B. All right, so we're just proving our application load balancer still works. We'll go to instances, day 3, web A. We're going to instance state. We're going to just stop it. We're not going to delete it. We're going to stop it. And then we're going to go back to our target group. And we're going to see A say unhealthy again. Click into it, go to targets, refresh. Give it a minute because it's still, B's gonna say healthy. The top one's gonna say healthy, and the bottom one's gonna say unhealthy or unused. So we're still waiting for the first one to become healthy. So let's give it a minute. What happened to B? Oh, we put a filter. Sorry. All right, boom. That's exactly what we wanted to see, and we are gonna refresh the web page, and only B is showing. So, yep. Now we're gonna go back and start that instance again. Do instance state start, and then once it loads, we're gonna wait for it to turn healthy, and then we're gonna refresh the page, and we're gonna see A and B on the web page. So it's initializing. Let's give that a minute. All right. Both are healthy, and we're going to do a refresh, and we see server A and server B. We are good. All right. All right. So all 4 breaks we proved. These are different failure scenarios. So first break was nginx stopped on server A. ALB routed around the failed app. Break 2 is a backend security group blocked the ALB traffic. Instances / nginx stayed up, but targets went unhealthy. Break 3 was a bad health check path. Healthy servers looked unhealthy because the ALB was checking the wrong endpoint. Break 4 was the entire server A stopped, but the application stayed available through server B. That means you now understand the difference between compute health, application health, network permission, and load balancer health and redundancy. Before the quiz, just make sure day 3 web A is started again. Both targets turn to healthy. Yep, they're there. Yep, it's back and healthy. Day 3 quiz time. All right, we're gonna finish this night off with a 10-question quiz, and that'll be it for this lesson. All right. An internet-facing application load balancer is placed in 2 public subnets, while its EC2 targets are in private subnets. Why can the ALB still send HTTP traffic to those private EC2 instances without a NAT gateway? It's not B. It's not A. It's not C. It's D. It's A? Traffic from the ALB to targets in the same VPC can use private addresses in the VPC local route. So it was using the local route. Okay, that makes sense though. A backend EC2 instance shows running in the EC2 console, but its ALB target status is unhealthy. Which statement best explains this? A. Yes, it can. Your EC2 can run even when your ALB is showing unhealthy. Um, that could be because the path is wrong. There's many scenarios where that could happen. Server A and server B are both healthy ALB targets. You stop nginx on server A while leaving the EC2 instance itself running. You stop nginx on server A while leaving the EC2 instance itself running. What should the ALB do after server A fails enough health checks? It should route to server B. Easy. Both web servers are running nginx correctly, but you remove the backend security group rule, allowing TCP/80 from the ALB security group. What happens to the ALB target health? Well, nginx doesn't stop. Exactly. B, the targets become unhealthy because ALB health check traffic can no longer reach port 80. The ALB target group health check path is changed from slash to slash does not exist. Networking and security groups are correct, and nginx is running. Why do the targets become unhealthy? Because we don't have a web page on slash. There you go. Response. It's a non-existent path. Why is it better for the private web server security group to allow TCP/80 from day 3 ALB security group instead of allowing TCP/80 from just the internet gateway? It limits backend HTTP access to traffic originating from resources associated with the ALB security group. Exactly. Security group referencing narrows the allowed source and avoids broadly permitting HTTP from every IPv4 address. Server A is in US East 1A and server B is in US East 1B. Server A is stopped completely, but the site remains available through server B. What design principle did this demonstrate? Server A is in US East 1 and server B is in US. Server A is stopped completely, but the site remains available through server B. What design principle does... Oh, availability zones. Fault tolerance through redundant healthy targets across availability zones. A user opens the public ALB DNS name over HTTP, which sequence best represents the application request path to a healthy private EC2 backend. A user opens the public application load balancing DNS name over HTTP. Which sequence best represents the application request path? Wait. So we open the ALB DNS over HTTP. Oh, so we're learning the path. Okay, so the client hits the ALB, and then the ALB moves it through the target group, which hits the private EC2 on TCP/80, and then the application. Both targets suddenly become unhealthy because curl local health succeeds, but curl succeeds on both. Which issue is most consistent with that evidence? Network permission or ALB health check configuration problem between the load balancer and the targets. Yep. So the successful local host request shows that the app is responding locally. So you know it's either the internet or the ALB target. That would be the issue if the curl wasn't working. What is the primary job of the target group in the day 3 architecture? It is to receive traffic. Maintain the registered backend targets in their health so the ALB can forward requests. Money. Nice word. We got 9 out of 10. Again, your boy got 9. Last night I got 9. It's all good. We did good today, guys. Thank you so much. Day 3 is complete. Day 4 tomorrow. 60 days in a row. We're going to keep doing this. Love it.